basically about content profiles. So the long and short of that one, really, remember what we're talking about? We're talking about if I want to, let's say, bring in a spinning shoe, you know, to my world, and it has some PBR appearances to it, you know, I don't need, you know, all of this other scene graph junk, right? And all these other nodes that might be there. I need this set of stuff to represent my information, right? A mesh, an appearance, materials, and a way to work with the lighting, right? So in that sense, like, we don't need like all of the metaverse capability to, you know, link that kind of content. And so that's really what we're going to dig into today, is how, you know, Web 3D has evolved to think about content in a pretty modular way, and a way that is extensible and can be conformance tested. So that's really what we're going to talk about today, and look at lots of examples. A lot of the examples, well, some of them are going to be motivated from this use case, but you've seen this sheet before. So I'm going to continue down to our projects. So these are the things that we identified through our initial discussions and are on the web page. So we're going to dig into the second one. All right, so we can build up our scenes from a variety of resources. And in order to compose a scene, right, we need to know what's in those resources. What can we expect from them? And so that's this idea of a content model and a standard like X3D and GLTF, right, that have basic scene graph structure. So I'm going to dig into this. This is linked from our original agenda. Just to introduce folks again to my background, I'm here with the Virginia Tech hat on, where we've been building reproducible virtual reality, scientific design, engineering applications for 25 years. Our stuff still runs, and because of we're used the ISO standard, so that helps us really achieve our mission every day. And you can kind of see how we deliver that content, like here in the image. That's the same content. It's 3D Blacksburg shown on 4 different platforms without recompiling. It's the same X3D scene graph file, right? From GIS and all the things that we built it from. So cave, stereo TV, headset, phone, laptop, the same file, same content. That's cross-platform. So you'll be able to see kind of how some of the applications and so on that are in my publications through the channel. Obviously, we're talking about a big deal. So I just sort of motivate here a little bit about the numbers we're thinking of, but 5.3 billion global users, 97 million users in the last 2023. This is serious. So clearly, we all on this call see the value in interactive 3D data, and not just virtual reality, but augmented. Here you kind of see some images from our Visionarium lab, and again, this is X3D content that runs also on a mobile phone and a desktop, but able to give that experience accessibility, right, to lots of different stakeholders. Sometimes it's the town council, right, looking at a new park. Sometimes it's students talking about their landscape design, or artists. So having that accessibility of the 3D content is really what my lab focuses on. And you can kind of see, again, over the years, how my students, undergrads and grads, are building, real applications that we can also access with a whole set of different devices, right? Here's young kids at the science fair flying through 3D Blacksburg and looking at the stream gauge data, right? to the caves, to the phone and the headset and so on. Okay. So this cross-platform nature, and the idea that our group is here for, right, is thinking about how we use the web to make this metaverse content accessible. And what's really exciting is that there's a lot of that is in place and in the ecosystem. So I'm going to kind of use this use case to kind of motivate us a little bit just about how, or what we have today, right? So the fact that this content, now we have, WebXR as a standard. That's a whole new set of devices to make this scenes accessible. And then I'm going to use the field trips as kind of like a way to think about, introduce and think about this idea of profiles and components. Okay. So this first one, and I do have to apologize, we just found there's a bad bit in the codec that Apple doesn't like. But if you have we've fixed that. But if you have an Android and you wanted to take a look at this, right? This is a USDA project where we're doing virtual field trips, right? We're training people. So there's a whole bunch of sites they visit. It's driven by React. There's multimedia, video, maps, all kinds of things for these sites. And that is accessibility, again, has been a key thing for the USDA, and they're able to train their foresters, right? Hundreds a year are using this curriculum to get their professional certification. This one is another great one. This is about training. We actually are building in construction. So this is NIOSH, the US Safety Hazard Project. And here we built a whole set of, rich 3D scenes, but, they basically couldn't run anywhere, right? So what we did was we rendered them to 360 equirectangular video, okay? And then we put them on the web and into the cave, as you see here. So we can take the students to this very dangerous construction site, and they can pick out all of the safety violations in the scene, for example. Something we could never do in real life, obviously, right? So that's the thing about the accessibility and the fact that I can take lots of different kinds of media, not just shapes and material, also multimedia, right? Videos that are spatialized and located. Web audio, right, which has all kinds of filters and cool stuff. So it is about multimedia. And when we think about what makes the web go round, right, we're going to kind of think about these four things. So this is, you guys can see, is Sponza, with an interactive demo. So it's an X3D world decorated with, I'm sorry, it's a GLTF world decorated with X3D. So the shadows, the interactivity, the physics, that's an X3D, but it's a GLTF model. That's X-Freedom running in our cave with head tracking and stuff. So it's really amazing what JavaScript can do these days. We'll go into more of this. But obviously, the power is the emergent linking of all this information, right? And what you get by putting it together. So as a mashup, and the web is really primed to be able to pull lots of different MIME types together, to be able to maybe, click on a 3D object, go out to the web and get some information like the weather at that place and bring it back, right? So we can really mix 2 and 3D content these days, and it's exciting. Now we know that there's different ways to be cross-platform, and I'm only bringing this up because I think that we're mostly going to be focusing on this case today, but we know we've discussed that there's other ways that the web and metaverse applications might interact, where maybe we don't have the traditional browser, but we still might have a user agent working on your behalf. So here's some resources for folks to look at what the Web3 Consortium has been doing and all of that work there. And we're going to spend just again, some quick time getting you oriented to what's in that standard, okay? There's a lot there, so I understand that it's a little bit daunting, right? If I'm, one of my undergrads who writes this kind of code, it's a little daunting. But like we say, well, there's 25 years of material and ways in, so that if my undergrads can do it, I'm sure your professional developers can do it. The main thing that I probably to start with is the idea that it is a scene graph, right? It's a content model, kind of like GLTF, right? You have certain nodes and fields and this parent-child relationship. But what's different is X3D actually has several different encodings for that scene graph. So the same scene graph can be written in XML, JSON, UTF-8, brace bracket, binary. Okay, so whatever your content pipeline is or your exporters, you might see X3D that actually looks different. It's encoded in a different way, but it's the same scene graph. Okay, and that's what the standard describes. The second thing to think about is that it's not just JavaScript, right? We're going to be showing lots of examples, and most of them are JavaScript. But if you wanted to write an API or service in another language that created X3D, there are standards for that, right? Including inside the consortium working on these ones are pretty active right now. We're reviewing some drafts. So encodings and runtime bindings, a lot of flexibility there. Now, the other sort of architectural way that X3D is structured is this idea that it's not a monolithic standard. Okay, so people remember VRML. It's still a standard, still stuff runs today in my cave and everything, but it was a monolithic standard. It was a 212 nodes. Like, who wants to implement 212 nodes if all I need is a spinning shoe, right? Same with USDs, like 2,000 something nodes. So good luck. This component scheme and profile scheme is how we approach that problem, okay? And this idea that we have a core set of functionality in our scene graph, which is maybe transforms, parent-child things, content around geometry and appearance. And, oh yeah, maybe if I really needed to respect my CAD hierarchy and parts, I could use a special CAD node, right? That is in my profile. Or maybe I'm actually only worried about interchange of medical data, right? So I need volume rendering, I need some text, and my regular shapes and lighting. So I might make a profile that just has that functionality in it from X3D. Right? And so you can build in this sort of Venn diagram idea profiles out of components. And I'll show you exactly what that looks like in just a minute. And this is sort of one of the ways, the benefits of that extensibility, right? So writing a new node, oh wait, there was this thing called programmable shaders and XML. Yeah, we extended the language to support that. Then there was, WebGL. And so we started to look at how that works with the X3D scene graph. Now we're into physically based rendering. Oh yeah, we extended the scene graph for that too. So this extensibility is what's made this common core standard scene graph survive, literally, for 20 plus years and evolve with the industry. And by the way, all the stuff that I wrote in '97 still runs today. And I need that as a scientist and a researcher. So layered profiles, everywhere from the spinning shoe up to an immersive, rich environment with interactivity, head tracking, physics, GIS projections. These are all ways that we collect components, and then we can have conformance tests against that functionality. So components are supported at levels, and profiles wrap up these components. So let's look kind of like what that is. Maybe we'll go really quickly here. Oops. Standard recommended. We'll go to X3D4, abstract node definitions. Okay. So again, kind of just to orient you about what's in this ISO IEC standard, we're looking at a bunch of components. And yeah, it looks like a lot, 42, right? But you can kind of see that they're all basically working with specific kinds of functions, right? So yeah, if I don't need rigid body physics, right, I'm not going to include the nodes from this component, right? If I'm not using CAD, I'm not going to do that. Similarly, NURBS, volume rendering, particle systems. But there are some things that are really common. And so we'll see kind of here on the right how the different profiles are defined, right? So the MPEG-4 wrapped up a node set. We also have a medical interchange profile here. I know our volume rendering group met today. But so, what are the nodes that you need to conform to that profile? And what you'll see in these tables is basically like the name of the node and then the levels of support, right? Like I need to have at least this many points to be able to load. So that's conformance. Support levels. Let's see. So you can go in with the spec and actually have confidence that that asset or that piece of metaverse experience, right, which is supporting some profile, my spinning shoe, my bling, whatever it is, and the engines can conformantly see what and expect what's coming, right, what's coming down the pipe. The ability to make new nodes, you can also build off of, the X3D hierarchy. So there is all these nodes and node styles, right, are built in an encapsulated way so that you can actually extend the node type with your own custom node, right, and you inherit all of that, all the semantics of the scene graph there. Okay, so that's a lot of talk. Let's see what it really looks like. So, in our community, we have a number of open source engines, including game engines, if you want to install and build stuff, or, these JavaScript-based engines. And one of the cool things with X3D4, right, is this idea that, again, we're extending the scene graph because there's this cool thing called GLTF. You guys remember the JPEG of 3D? Well, JPEGs are great, but to make a real web page, I usually need to have several JPEGs. They need to have some interactive logic and to do something with them. So what we decided to do was X3D4 includes GLTF, and in that way we can use X3D for the other stuff like the lighting, the physics, the other kinds of things we need to specify. So there's two toolkits that we'll look at too, and look at some examples. So the first idea about the strategy, this is a few years old, but it's the idea that you have kind of this Venn diagram, this ever-expanding kind of functionality, and GLTF is really, it's in the core. It's like a JPEG or something that's lean and mean for an asset interchange format, but it doesn't have a lot of things that you might want to be reproducible about, like navigation and lighting and so on. So we can actually describe our scenes at a higher level. Those scenes can be run with WebXR using XFreedom. So let's just go around and see a couple of these examples. So it's not, really rocket science here, but we'll load one of these models. And yes, looks great. We've got the GLTF, the texture, the nice materials, so on and so forth. But this is actually an X3D scene, right? So we're using X3 DOM, and we've got a few menu things here, but where's the content? Here it is, an X3D tag. I've got my navigation info, I've got my stuff, oh yeah, and then here's this GLTF assets and GLBs, right, that I'm loading. Here they are. Okay. So pretty cool. Now that's great to be able to like make a scene out of lots of GLTF. Things like really useful. But there's more, right? So some of the things that we started to play with in our member world was, using the document object model part of X3D to do interesting stuff, right, with our GLTF models. So yeah, we can put several models into a scene, and that's great. But we can also kind of control different interactive things like their animation, right, through the X3D language, right, and through the DOM. We can control the viewpoint, right, of these. So you're kind of starting to see how X3D lets us kind of glue together these GLTF worlds and add interaction, add application logic, and other interesting stuff. Okay, that's cool. But is that all? No. In fact, if I wanted to bring in a piece of GLTF into a scene, what else can I do with it, right? Is it just really like a black box, like its own namespace? And the answer is yes, it is its own namespace, but you can reach in and grab that as a programmer. So here we have some SVG, right, controlling the pause and play animation inside that GLTF. Right, but this is an X3D scene, so if I wanted to kind of maybe look at what's happening here, let's go into the scene, and I want to go to my X3D element, kind of dig into the DOM here. There's the X3D, that's great. Canvas, scene, here we go, the scene. Let's expand that a little bit. So yeah, through the DOM, right, and my console, I can reach in and see that GLTF asset. Not only that, but I can grab the animation that's inside that GLTF and control it with X3D and the DOM, right? So I'm actually able to dive into these, into the GLTF files inside X3D and grab an attribute, change an attribute. Okay. So kind of starting to look like maybe the DOM is a pretty good organizing principle even for 3D graphics. And we know that there's some very sophisticated things going on in terms of like the DOM actually has a shadow DOM and the way that CSS and events bubble and so on and so forth. But that's a performant platform. All right, I'm going to do one more, and then I want to take some discussion time. So another example of kind of how our community extends the standard and brings innovation and does it usually in the open source is this other toolkit called Excite, which we really like, and also has an editor called Sunrise Editor that you can build. It's a Node application, easy to build. But I wanted to kind of share. Let's look at these. Excuse me. I'm not sure which is which. Okay. So here's an X3D scene. We're using this idea of instance geometry, right? And I can go full screen and do some things with my Excite browser, jump to, right, predefined viewpoints, so on and so forth. But what is really interesting here is that this is actually the Excite playground, okay? So I can look at my scene graph in a number of encodings. You can see in the upper right. I'm looking at it in XML right now. So this is actually the X3D file, right, that we're looking at in here. It's one humanoid, as you can see, but it's instanced. And what I want to do is find a time sensor, right? And so one of the cool things is that these are, let's see if we can speed this up. Or slow it down, actually. So I'm live editing my 3D scene through this DOM, through this editor, right? I just changed it. Let's go actually make them walk a little faster, right? My bad. There we go, right? So this is what X3D looks like the HTML way, right? This is how this convergence lets us inspect, modify, right, in real time our scenes. So I love this this editing system. Let's bring up this one again, because this is kind of also a neat one around. Okay, it's particle systems and physics for with, you know, taking into account some geometry and some damping and this and that. But one of the things that, again, we can do in our, with the editor, right, is actually literally change any of these parameters, because we're editing our scene live, right? So we could actually remove the shadows, see what happens if we take that out. Back up a little bit. There we go. There must be another light in there somewhere, this environment light. But kind of seeing some convergence here, the web as a platform, the web as an editor, the web as a way to distribute our experiences across platforms, and to be able to kind of, let's look at this playground. Here's the thing that we should end on. Look at the header. So I have a profile, interchange profile, right, which is pretty basic kind of stuff. But hey, I also wanted to add particle systems and some 2D geometry and cube texture mapping component. You just declare them in the header, right? And now you know that the node set that you're getting, right, is you can validate against those GTD and schema and know that you have legitimate content that runs that functionality. So a lot of fun to think about ways that the international standards today kind of approach this as, from an architectural point of view, is like starting simple, building up, and providing a way that authors can really mix and match, right? Or systems can mix and match which bits of X3D spec they really care about. And then they can extend their own nodes. So really excited about the GLTF stuff. I think we'll have to see, you know, where they're things are landing. It certainly feels sometimes like when they add physics and all of this stuff, it's not really so lean and mean anymore. Or it's not really the JPEG of 3D anymore. It's got a lot more in it. So there's a convergence happening in these functional profiles, these levels of content. And that's exciting. That's where we're living as a group here. And so I hope that we can kind of use this presentation here to have some more informed discussions around profiles and around some other activities here. I'm kind of thinking that what we do is we have some great examples, right? And we're going to provide some kind of blog or report. And so hopefully we can, as a group, we'll be able to use this information and make some good recommendations about what's the art of the possible and being able to do that with open tools and open standards. So yeah, so that's it for the presentation part. Let's take a couple minutes here and talk about content profiles and what that might mean for our work. So let's go back here. That interchange profile, right, which we were looking at in Excite. In this case, there's not anything about interaction, right? Sensors, X3D has a whole set of sensors involved. That's in the interactive profile. But in the interchange, right, I know I'm going to have a scene. I want to have lighting. I know I'm going to have to, navigate it. Maybe there's a background and fog, right? So these are the things that are in the interchange profile. And as a handful of nodes, it's very much more tractable to implement this, right, than the entire X3D spec. Right? If I know I want a spinning shoe, these are the nodes I need for it. If I need to do something more interactive, I might choose another profile. So let's take a look at, I'll bring up just which profiles there are again. So thoughts, reactions. How are we doing? Did I make any sense?
Yeah, so you talked about physics. Are you expecting those to be in the interactive profile then?
Great question. Yeah, let's take a look. Is physics in the interactive profile? And I don't see.
They're going to be somewhere, right? So
yeah, it's probably in the immersive, maybe. But
okay.
as we saw here in this example, right, we could start with the interchange profile and then add physics. So maybe if we go back here, they have some nice examples that are using physics. Where is that? Particle system.
Just that I was just thinking, if you've got like maybe a football or something and you're bouncing the football, right? Obviously there's physics associated with. So
Go back 2 pages. There was one example. Oh yeah, please.
Yeah, I'm seeing.
Lights
The
are
lighting is. So yes, so I think that would be the kind of the idea, right? Is that I would let's go back. I would be able to define in my application, right? I want the interchange profile, but also physics. And so the physics is, where did we go? Rigid body.
well, anything with the rigid body is going to have physics associated with it.
Yeah, the there's been some talk about soft body physics too, but we haven't had a member who's really taken that on. But so we have, I think, an approach then is if we start to think about, interoperability on the web as not just like HTML5 or, one big standard, but we actually think of it as a nuanced, composable kind of a place where, yeah, I can still be standard to the conformant to the standard, right? But I may have like totally different nodes in my application than you do, right? If I'm doing medical stuff or CAD or GIS, right, that's a different set of things than maybe I need for, right, a consumer storefront or something. And using the scheme of components and profiles, we can do that. So great question. When you look at these kinds of lists, like it looks like a lot. You'll see, yeah, shadows in the lighting component. Humanoid animation, that's also an ISO standard, which you saw in that demo. So there's a lot there. And I think for today, like our goal is really just to kind of see what it is, try to understand, right, the variety of ways that you might compose a metaverse experience. And that not only that, but we can use the DOM to really to drive applications around with 3D. So going to using all our HTML widgets for sure, that's nice. But also being able to like edit it right in a live page.
A question about the shadowing. You mentioned shadowing. So with the shadows, do you also have like occlusion, like shadow? So if like two objects meet, you automatically put a shadow against the intersection, that kind of thing, or is it just shadows, an object casting a shadow? I create 3D worlds, right? So I'm just thinking of all the things that I normally have to do and I have to think about. So that's why I'm asking these questions.
Yeah.
Direction and light.
So, yeah, it's in the lighting component, and we've seen some different, and you can look at XFreedom and Excite, they both have shadows implemented. Where they might have, for example, one of them has a parameter around like how resolved you want the shadow map to be, right? So you could have kind of rough ones that run really fast, or you can have high fidelity shadows. It's a little slower, but that would be under author control, right? And so, yeah, I think you can dig into those. There's one example here which really shows this, sorry. And it's this one, which last time I did it, it crashed with Chrome and Zoom, so I'm gonna try it with another browser. It's very risky, but actually you could do it. So again, it's a couple of GLTF models lit with X3D and using X3D sensors and the DOM programming to make this kind of idea that like point the camera, click the camera, get a postcard from the metaverse, right? So you'll see it'll load a screenshot into that page after you take one. So yeah, you'll see
going back to the profiles, Nicholas, going back to the profiles. I know we have an immersive profile. If you can go back to the profile page. Do you see us coming up with the Metaverse profile? Or it would be part of immersive, or we would have to just a minimum profile that would be required to create a Metaverse world?
Yeah, I think that's a great question, and that's probably part of the strategy, right? One of the things that I want to mention is that, you know, as you saw with the Excite example, today authors can mix and match this functionality, right? You just list the profile and then you add whatever components you want.
Mm-hmm.
So in that sense, I think, you know, that's something you can do today. The next question is, like, as a community, what do we want to do? And I would think that, yes, if we were able to hammer on it from all the different directions and shape it in this way, like we could do that as a community, right, profile before we go into all the standardization stuff, right? We could all sort of agree in the standards forum that here's this node set, right, that we know we want to support, and let's start with that.
Mm-hmm.
So I definitely think somewhere between interactive and immersive, right? Some of them are, yeah. And, you know, we had some discussion about links the other day, and so points of interest or geopose, right? Those are, we might want those for a mobile application or something, right? And so
need them for my use case, Nicholas.
Yeah,
Right.
when you build a use case, you can include, you know, you can define which are the profiles you would need. And
I haven't yet, actually, because the use case does request geospatial. The consistency of experience use case does require geospatial because you need to know where you are in the world. But yeah, no, I hadn't looked at this list because I hadn't seen this list before, so I didn't reference it at all when I was writing the use case. But that's kind of quite interesting, Anita. Yeah.
Yeah, I think that's exactly the kind of things we should be doing and discussing, right? Is like the trade-offs around these different components of functionality. So one of the things about the X3D geospatial component is, I mean, it's quite powerful in the sense of being able to support not just your Web Mercator stuff, but if you actually want to use like double precision, like engineering data, like from survey stuff, you can put that into UTM. And so X3D, again, like its geospatial lets you kind of mash up different coordinate systems in the same scene. And the question would be, well, you know, like, so, you know, this is the one that 3D tiles supports, right? It doesn't support any of these other ones, but X3D gives you the option, right? So this may be the more like common one on the web that we're used to using with like web maps and, you know, different kinds of query services, USGS, for example. But there's a lot in there. And so one of the things that we could do is each component at the bottom kind of has this support level table. And the idea that, again, that's sort of like growing the functionality into these subsequent levels. You can see, like, as I get more advanced, I'm getting a little functionality, like I'm getting these two other nodes in that level to support.
Yeah, because in my use case, because I know that the another working group, the guys that are working on you know, the intercept between the real world and the virtual world, those guys are working on geospatial and so on. So I just kind of put in the use case, I just kind of reference those guys because I hadn't realized that you were doing this at all. I had no idea. So I hadn't even added that to the use case. I mean, is there could you just share the link to this in the chat so that I can easily access it? That would be good. Because I had no idea about this. I really had no idea.
Many folks don't have any idea what X3D can do, really. Tracy, coming back to the GeoPose, I think OGC has a component for GeoPose, so you may also want to look at that.
Yeah, I've looked at the GeoPost stuff. Yeah, I've looked at the stuff that they were doing on. Yeah, I've actually read the document on their website as to what they were actually doing. So that was quite interesting. Yeah. So, in terms of another question, in terms of lighting for this, because this is web-based, and obviously this is being rendered on a server before actually being transmitted to the device, is it? No?
No, it's rendered on the client. Both of these examples
client,
I've showed
okay.
today.
Mhm.
Yeah.
All right, okay. Well, I'm just wondering then about lighting. Do you have the concept of baked lighting versus real-time lighting?
No,
It's
it's
just that
real
not.
time.
So we're all real-time lighting.
Okay.
So
If you have
the
baked
standard
pictures in
shadows,
your
but you
scene,
can use we can use shadow
Shadows,
maps, pre-computed shadow maps or lighting components on surfaces if you pre-compute your lighting. So there are a couple of systems that just pre-compute from whatever system, and then they use vertex colors or anything. But that's also something you can combine. So real-time shadows with pre-computed shadows. So that's something that works.
Yeah, I
in
mean,
both implementation.
the reason
Yeah.
why I
So
ask
if you
is that I normally build for virtual reality, so for headsets, so that the application is on the headset, so you are rendering on the headset.
yeah,
So and I create very large environments. So the majority of the work that I do is trying to optimize it so that I can keep the frames per second above
Yeah.
60 frames per second, right? And so I do a lot of baked lighting in that instance. That's why I asked.
yeah, but that's something you can utilize here also. So if you pre-bake your lighting in a specific texture and put this texture into a X3D or GLTF file, then both will work.
Okay.
So this is
how you would do it.
you can
Okay,
do.
yeah, I get it. I get it, yeah.
Yeah.
Okay.
And what also nice is that's really powerful. All this works right into on your in your HMT, or so it's not just a web browser, but or not just in a 2D web, but it also works with WebXR on your classes. So you can use whatever classes you have. And it's not fully supported yet, but it's on the way to there. So WebXR support is now in XFreedom and will be extended.
Sorry, how does it exactly work with the WebXR? The immersive profile, it's really possible like to use the device API and start an immersive
Yes,
VR
it is.
session like WebXR?
Yes, this system supports WebXR already. So it had support for WebVR for a couple of years, and the latest version now has support for WebXR.
Oh,
So
nice.
this is like kind of like the kind of thing that you could do with like Mozilla hubs, right? That kind of thing.
Yeah.
Another maybe. Yeah, you wanted to show something?
Well, I was going to basically just kind of show that, you know, I have the WebXR browser emulator installed.
Mm-hmm.
So, you know, I can go in and basically run that content and send it to a WebXR session just with that button. So that's XFreedom 1.8.3, which is the current version. And love to work on that more. My master's student and the XFreedom team implemented that. So again, I'm sure professional developers could maybe do it faster, but yeah, my students were the ones who added that feature in. And so there's still work to do. But yeah, if you have a web device, we've actually tested it on in my lab against basically like 8 different headsets, including the latest 5 in Oculus. So it's working as expected.
You can also like render HTML in the immersive view, because WebGL can't do that at the moment yet. What you do is basically you create a canvas texture.
Exactly.
And I the same.
So you don't have, no, you don't have the HTML, but that's also not, so you expect to have this full 2D web page on a 2D device, but on immersive device, people usually don't expect to have this 2D view, but they expect to have some immersive spatial experience. And that's something that the system also can provide. It's not yet totally fluid, but it will get there. So at the end, the web, there's an immersive VR and immersive AR subsystem in the WebXR component that actually can support different spatial profiles. And that's something that will
you can detect your device then. You can detect it, basically you can detect the web browser you're on. So if you're on like the Quest 3, it knows it's a Quest 3 browser, and therefore you can press the button to go enter VR basically on your web browser. Yeah, okay.
So it's the whole idea is that you get some, like the idea that with a progressive that the application actually realizes what kind of device you have, what kind of capabilities, and then decides if you get a 2D or extended 2D or fully 3D SSH. So that's what the systems will do at the end, I'm pretty sure. Because it doesn't make sense to show a 2D website on.
Yeah, it sometimes makes totally sense, to be honest, when you're in an immersive room in 3D, right? And maybe you want to walk with your avatar to a screen, and
of course there are other aspects like UIs in immersive environment.
Same is also for HMIs, controlling robots and machines and so on. You want to have the kind of user interface in 3D room as well.
Exactly, but that's a different aspect. So there, it's a UI aspect, and the UI aspect can be 2D in a 3D world. But that is then content of the 3D world. That's something that already works in X3D or in X3D anyway, because you can just put a video texture or some other texturing, external texturing, have an external video source. That's something people implemented already years ago.
Yes.
That you have a feed from yet another web server that provides the JPEG feed to your texture site, to your texturing.
Thanks. Yes. Maybe another question, if I'm allowed. I have a use case where, for example, you have a room with thousands of different avatars, right? Humanoid avatars, and they are like GLTF models, and you don't really want to have the animations, like let's say 20 different animations for walk, run, jump, and so on each of those avatars, again repeated. So you want to have them, for example, as FBX animations, and then just apply them on the avatars. Yeah, this one is just instantiate mesh, where you have the same mesh, but imagine you have different avatars, different models, but the same animation, because it's just humanoid animation, like Mixamo animations, if you know those, the library from Adobe. Yeah, a way to load the FBX animation or something similar like that, and then apply it to the existing model, so you don't have repeating resources, right?
Yeah, definitely there is instancing and name addressing in a global ID space. So even if you wanted to do it in the DOM, you could do it. But in the X3D data structures, for sure, you can reuse animations. And the HNM group has actually done a lot of work on that, because different avatars have different arm lengths. And so, how do you actually do that or maybe I'm missing an arm, right? So it's it's quite an interesting problem. And in web3d.org, there's a humanoid animation group. It's mostly driven by our Korean members at the moment, although Germany did a bunch recently too. But great questions. I love this discussion. And I know I want to be respectful of folks' time, so we're at 5 after the hour, and I'm really glad that we had this time together. I would like to continue these discussions online, and we will have another working meeting next week, and then another group meeting the following. So we'll look forward to seeing you at those.
I do have another question for you, which is, how do you deal with occlusion? And because normally if you've got a VR headset on, the VR headset sees through walls even if you don't. So it's basically rendering everything regardless of whether there's a wall in place or not. So I was just thinking from performance, how you handle that. You don't need to answer it now. Just
no, I'm sure there's that's a great question. A bunch of culling techniques that are in the standard, but different ones in the toolkits too, in terms of culling. There's a great sensor called a visibility sensor in X3D, which you can use to do some logic around things, as well as the culling outside your field of view. But let's dig into that next time.
Okay.
Really
for my question on my use case, what should I do, Nicholas? Shall I just email the team, or do you want me to email a particular you personally? I don't have your email address if you want me to email you personally, or I can just send it to the group.
I think send it to the group, because that's what will sort of spark a wider discussion.
I'm okay with that, actually, because it's a group thing, right? So everybody needs to know the answer, right? So I'm fine with that. Okay.
Yeah, let's do that. Great. Okay, thank you, everyone.